In calculus, there are things which we call polynomial expressions. They look like the following. In this case, a and b are constants, so you can plug in any number you want, but if you define these two, then you can't change their value again while working at the same equation. Their value is constant. X, on the other hand, is a value, so it can have multiple values. Another example of a polynomial would be 2x cubed plus 3x squared minus 7. You can do many things with that function, but the two big players of calculus are called derivatives and integrals. They are opposites of each other, but today we are going to talk about derivatives after the intro. The notation dy dx or f prime of x is used to represent a derivative of a function y with respect to x. To find the derivative of a polynomial term, which we are going to call ax to the power of b again, we use the formula. The derivative of ax to the power of b is equal to bax to the power of b minus 1. So we simply just put the exponent b before our constant a and then subtract 1 to our exponent. So let's say we plug in 2 for a and 3 for b, and our derivative would be 6 times x to the power of 2. Let's say we have a car which moves over a given distance for about 10 seconds. The car accelerates at the start, stays constant for a while, and decelerates at the end. Yeah, I'm sorry I couldn't find a better car image because they cost money. Sorry. Now let's look at the function. The gray function shows us how many meters are traveled at a certain time. If we take the derivative of this function, then we get the speed of a car with respect to time. Let's take the steepest point of a distance traveled graph, for instance. That's the point where the car travels the most distance per second, which is why the velocity function has its maximum there. See, if we put everything in context, then even math makes sense. As a rule of thumb, you can memorize that on the points of a graph with the highest slope, its derivative is going to have a maximum or minimum there. So the derivative shows us the nearly instantaneous rate of change over a given time. Now let's look at our good old friend x squared. If you plug something for x, then you can also draw the rate of change as a tangent line, which shows us the rate of change at this specific moment by looking at its slope. To get the equation for the tangent line, we need to solve for the equation y is equal to mx plus b. Now we already have the y value 4. Now we plug in 2 into the derivative to get the slope. If we now plug in 2 for x, because that's where we want to get our slope, we can solve for b and get our tangent equation. Another way to see the rate of change is by drawing a secant, where you basically take 2 points of a function to see the rate of change over a given period. The formula is y2 minus y1 divided by x2 minus x1. If we now plug in the points, we get our slope. There are also some helpful rules to learn while taking derivatives. If you have the fraction 1 divided by x, then you can form the 1 divided by x into x to the power of minus 1 and take the derivative from it. Same goes for 2 divided by x squared, which would be 2 times x to the power of minus 2 and so on. If you need to take the derivative of x, then it would simply be 1 times x to the power of 0, which would be 1. The derivative of 5x is equal to 5 times 1 times x to the power of 1 minus 1, which would be 5. And the derivative of a constant is simply just 0. If you want to, you can take a screenshot of it because the screen gets a bit full. Now if you need to take the derivative of a root, like in the derivative of the square root of 2x, then you can transform the square root into the exponent 1/2 and then take the derivative. Now if you need to take the derivative of a third root of x, then you can transform it into x to the power of 1/3. Same goes to the fourth root of x, which would be x to the power of 1/4. Now let's look at the derivative of the seventh root of x to the power of 4. As you can see, the 4 is going to be the numerator of exponent of x, and the 7 is going to be the denominator of the exponent of x. So we can transform it into x to the power of 4 divided by 7. Now let's look at trigonometric functions, sine, cosine, you name it. You just basically need to memorize them. You can take a screenshot if you want to. I give you about 3 seconds. To make the relationship between sine and cosine more clear, I'm going to show you a visual approach. I'm pretty sure that at least most of you all already know that cosine is the derivative of sine, but why is that so? Well, do you still remember the part where I told you about that the maxima and minima of a derivative are where the steepest points of the original function are? Well, if you look at sine and cosine, then we can see such a thing happening. Now let's talk about Euler's number, my favorite. So if we need to take the derivative of e to the power of v, then we get e to the power of v times v prime. Same goes for e to the power of x. So if we need to take the derivative of it, it would just be e to the power of x times 1, so e to the x. How convenient. If I'm ever going to make merge, I'm going to put Euler's number on it. Anyways, now pause the video if you want to solve it. The answer of that equation would be 8x times e to the power of 4x squared plus 2. If you got that right, then good job. If not, then I would advise you to watch the whole video again, because I would then get another view and you could learn your stuff. Now let's talk about natural logs. If we need to take the derivative of ln u, then it would simply be u prime divided by u. So if we have ln of x, it would simply be 1 divided by x, because the derivative of x is equal to 1. Let's say we need to take the derivative of ln of x squared plus 5. Feel free to pause the video if you want to. The answer of that would simply be 2x divided by x squared plus 5. Now if you have something like f of x times g of x and you need to take the derivative of that, you would simply need to use the product rule in order to solve that. You basically need to differentiate one of the two, so take the derivative and then multiply it by the other one, then do the same with the other function. So let's say we need to take the derivative of x cubed times sine x. The first thing you want to do is define both functions, u and v, or f of x and g of x, it doesn't matter how you call it. So u would be x cubed and the derivative, u prime would be 3x squared. Our v is sine of x and v prime would be cosine of x. So our derivative would be 3x squared times sine x plus 3 cubed times cosine of x. Now if you found this video helpful, then I would be happy if you could like and subscribe, and if you don't like this video, then you could also like and subscribe, because then you could comment on every new video I would make and criticize me. Thank you for watching.